So, you want to know what it's really like to study machine learning? Forget the high-level hype for a second. Today, we're going behind the scenes, peeling back the curtain on a real, honest-to-goodness university module to see what students actually go through to get qualified in one of the hottest fields on the planet. I mean, we hear about AI and ML everywhere, don't we? It feels like magic, but the reality of learning it, it's a grind. It's way more than just coding. We're talking tough theoretical challenges, massive hands-on projects, and a whole set of academic rules you have to play by. So let's break down what that student journey actually looks like step by step. All right, here's our game plan. We're going to follow this student's path exactly. First, we'll lay out the mission, the quest if you will. Then we'll dive into the core theory they have to master. After that, it's time for the big project. Then we'll get into the nitty-gritty rules of the game, and finally, we'll see what separates the good from the great. What does it actually take to get an A? Okay, let's begin. Our case study is a module called SWE 6204 Machine Learning. And you shouldn't think of this as just another class. Honestly, it's framed more like a quest, with a super clear set of objectives you have to nail to pass. Let's see what those are. So these are the 5 core objectives, and right away you can see this is about so much more than just memorizing algorithms. Sure, you have to understand them, but you also have to apply them, evaluate them, and, this is the big one, grapple with the social and ethical side of it all. That last one is a huge deal. It's not just can we build it, it's should we build it. Now for the first major hurdle. Before you can build anything, you have to prove you know your stuff. This first task is all about theory, and it's worth a whopping 40% of the final grade. You gotta show you have the foundational knowledge down cold before you even dream of writing a line of code for the main project. One of the classic concepts students have to explain is overfitting. Here's an easy way to think about it. Imagine you're studying for a test, but instead of learning the subject, you just memorize the answers to one specific practice exam. You'd get 100% on that practice test, no problem. But on the real test, you'd probably bomb it. That's overfitting for an AI model. It gets an A+ on the data it trained on, but fails miserably in the real world. And then you get these curveballs, k-means clustering and k-nearest neighbors. They sound almost identical, right? Easy to mix up, but they are fundamentally different. K-means is unsupervised. You just give it a bunch of data and it finds natural groups, kind of like a librarian sorting books without knowing the genres beforehand. KNN, on the other hand, is supervised. It needs examples that are already labeled to learn how to classify new things. Getting these two straight is absolutely critical. And here's where the rubber meets the road. Students aren't just defining these terms in a vacuum. They're given these 4 very different real-world scenarios and have to figure out which type of algorithm is the right tool for the job. Which one do you use for weather prediction, for finding patient groups, for content moderation? You have to think like a real data scientist, and that means choosing the right approach for the problem at hand. Alright, so you've passed the theory test. Now it's time for the main event. This is where students have to take all that knowledge and pour it into one massive, practical project predicting house crisis from a real dataset. And let me tell you, this project is everything. It's worth 60% of the entire grade. You can't just be book smart in this field. You have to prove you can roll up your sleeves and actually build something that works. This is where that happens. So the project follows this really clear 4-step journey. First, you get your hands dirty exploring and cleaning the raw data. Then, you pick and train several different models to see which one works best. After that, you take your champion model and fine-tune it, tweaking all the little settings to squeeze out every last drop of accuracy. And finally, you have to wrap it all up and present your findings in a professional report. It's the full data science lifecycle, from start to finish. But here's the thing, being a brilliant coder isn't enough. There's a whole other set of rules you have to follow, what you might call the hidden curriculum of the academic world. And frankly, this stuff can be just as important for getting a good grade. Check this out. The final submission isn't just your code. It's a formal 3,000-word report. And the requirements are no joke. Strict Harvard referencing, a solid list of academic sources, and you have to engage with actual peer-reviewed research. It's all about proving you can communicate your work like a professional researcher. Now this is my favorite part. In a class that is literally all about AI, students are explicitly forbidden from using generative AI tools like ChatGPT. How wild is that? The whole point is to force them to think for themselves, to wrestle with the problems, and to produce genuinely original work. In an age of AI, that skill is becoming more valuable than ever. And if you're thinking about procrastinating, don't. The penalties are harsh. Submit your work just one day late and you lose 10 marks. A whole 10% of the grade gone. Wait more than a week? It's a 0, a non-submission. In the real world, deadlines are king, and that lesson starts right here. Okay, so you've nailed the theory, you've built an amazing project, and you've followed all the rules to the letter. What actually separates an exceptional A-grade student from one who just passes? Let's pull back the curtain and look at the actual marking scheme. This table tells the whole story. Look at the C column. The words are sound, satisfactory, adequate. Basically, you did what was asked. But then look over at the A column. The language completely shifts to exceptional, thorough, critical. To get that top grade, you don't just use the tools correctly, you have to deeply analyze the risks. You have to conduct extensive research. Your final report can't just be good enough. It has to be highly professional. It's the difference between simply being competent and demonstrating true excellence. So there you have it, the real journey. It's this intense mix of deep theory, hands-on application, and really strict discipline. It's a gauntlet designed to forge not just coders, but critical thinkers who are ready to build the future. So after seeing what it really takes, the only question left is, are you ready for the quest?